Right, stationary wave. Whoops.
Last part.
I know, exciting, huh? Alright, stationary waves. So, a little bit to look at here. A standing wave, also called a stationary wave, is a wave that oscillates in one constant position. It can arise in a stationary medium as a result of interference between two waves travelling in opposite directions. What the fudge does that mean? Here's an example, but I'll try and draw this actually to make it a little bit clearer. So, imagine you have a string, like that, and you have a little arm here and a little arm here, and what this does is it shakes up and down here and shakes up and down here, and it makes a wave. Okay, and this wave travels through the string. So I'll try and draw it. Goes like here, and then it's here, 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 and then here it hits, and then it moves backwards, and so on. If you set this up just right, what can happen is when the wave hits here and moves backwards, it's exactly the same, but just upside down. So the wave, when it's heading backwards, looks like this. If this string is doing this very, very quickly and very fast, what it looks like is this. It looks like the string has turned into this, and it looks like it's not moving. So like it stays this shape. So this little point here actually doesn't move, whereas here it's moving up and down really fast. This is a standing wave, this situation here. So if you set the length correctly and the vibration correctly, you can get a perfect standing wave. A wave that doesn't move left or right, but instead just vibrates up and down. Kind of like a spring. This is a standing wave. Please write that definition down, and if you could draw the picture, that would be great as well.
Is that spring or light?
No, that's a string. That's a string, yeah.
So the middle part doesn't move.
Yeah, this little piece here. Is that what you mean? Yeah. Yeah, we'll actually talk about that in a minute. Yeah. Not this time, I'm afraid. We need 2 sentences. I know 2 sentences is twice as bad as 1 sentence.
Do we need to know the minimum fee to make this?
Oh no, not for this course. We don't learn the conditions to make this, just the result. Okie dokie.
What do you mean by stationary medium?
Oh, that it's not like in an ocean or something. That in this case the medium is the string, which is stationary insofar as it's not moving through space. It's not like you could do this in an ocean because the wave would just move away. Yeah, because what happens is the wave moves along the string, hits the end of the string and reflects backwards. So it's a reflection, and as it reflects backwards and it hits the next wave that's coming in, the two of them interfere. So it's interfering with itself. it travels along, it reflects, it moves backwards, interferes with itself, so that it looks like it's switching between being up and being upwards and being downwards. If you don't have the length or the speed correct, what would happen is the wave would run along, it might hit and come back. What are you doing?
Oh, the machine should be like this or like this and like this.
I don't know, because I said the conditions are not something we study. In fact, I just think it's just vibrating. It's not.
But
Hang on. I would actually like to show you it. How on earth do I get YouTube up? YouTube. Since you're so curious.
yeah.
Yes. Do you know this website?
No.
And I don't want to sign in. Right. Right. Stand-in. Stephen Hawking. Stand-in. Not stand-up comedy. Wave. Hey.
Can't make it in.
Not. Ah, yeah. This one looks like the machine. Make it good. Up and down.
Except this guy's here. When this guy pumps up and down, well, he sends a wave. Sends a wave down to this end, the wave reflects, comes back. Now, if I set it to just video frequency, well, no. So it's sending waves back and forth, but these waves are out of sync, if you will.
Yeah.
They're not exhibiting consistently constructive or destructive interference at any one point. But if I set it here, for example,
Oh my God!
I have what's called a standing wave.
There you go. Okay.
That is the wave that's sent down and reflects constructively interferes with the next wave that comes down right at this point. Now the waves that come down and reflect destructively interfere with the incoming waves right here. And that's called a node. I can touch it and it still is working. So the node is not moving.
Happy now?
Yeah.
Up and down.
Now how do I
Here's
stop
moving
this?
Up and down.
Okay.
Not this. Just
Up and down now. YouTube is so amazing.
Yeah, so smart.
So amazing. It's so smart, yes. Okay, did you write this down now?
Yeah.
Yeah. Okay, continue. Yep. So, you heard him use a word earlier, node. Node is a part of this wave. The node is the point on the wave where it has minimum amplitude, and antinode is the one where it has maximum. So these red dots here, these are called nodes. The blue ones that move up and down, they're called antinodes. Okay, so did I draw it here? Yeah. This here, node, 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 and node. And here, this is an antinode. No, I suppose you could say that point, or that point is an antinode. You see, they draw here. So, these are antinodes, and this one here is a node as an example. So, picture please, and the definition. Got that? Bruce? No. What the heck is that?
Banana, apple,
Banana and apple.
and beer.
Beer.
Yeah.
Beer.
Not beer. Beer. Pear.
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 Pear and beer are very different.
Yeah, I know. Nice.
Yeah, that would be unusual. Apple, banana, and beer. Just mix it all together. Okay, you got that?
Yeah.
Yep. Continue. Right. So, imagine that you know the distance between two nodes or two antinodes. So let's say here and here you know this distance, let's just call it x, or maybe you know the distance between a node and a node, we'll call that x. Could you know the wavelength? Yeah. Now what would the wavelength be? Yeah, like say you know x.
2x.
What would the wavelength be? It would be 2x. Sometimes students get confused here. But this, from here to here, that's one wave. X is the distance from an antinode to another antinode, which would be this one here. If that's x, then the wavelength is 2x. So, if you know the distance between nodes or antinodes, it's very simple to know the wavelength. It's just twice this distance. And I drew that already. So it's worth noting that the wavelength is twice the distance between nodes or antinodes. Sometimes the common mistake students make in the exam is they say the wavelength is the distance between the nodes or antinodes, and what they're thinking about is when we say the wavelength is crest to crest or trough to trough. That's the mistake they make. For this, it's twice node to node or twice antinode to antinode. If you can make a note of that, please, to try and remember.
Then if we know the distance between antinode and node, then wavelength is 4.
Yes, it is. Yes, it is. Cool. Got that? Continue? Yeah. Alright. If the string is held at both ends, forcing no movement at the ends become nodes. The length of the string then becomes a measure of which waves the string will entertain. The longest wavelength is called the fundamental, and half a wavelength fits on it. So, I'll try and explain this with a picture. Oh, actually no, I've got the picture here. So, imagine that you have a string. If you have one piece of string, you can pull it up, let go, and it starts to vibrate, okay? This is the biggest wave you can make, is this first one here. Now, in fact, you don't even have one full wave here. How much of the wave do you have here?
Half.
You have half of it, yeah? Because this goes from the middle to the crest to the middle again. And if you could if you could continue it, you would have another half here. So this first one here, this is the biggest wave you can make. And because of it, it's called the fundamental, or also called the first harmonic. Now, there is another possibility. You could have made this wave. This is the next, the next wave is this one here. And you might say, well, can't I make something in the middle? And you can't. Because if this is fixed and this is fixed, then this has to be a node. Okay, so you couldn't do something like this, where the wave is vibrating like that. If the end and the start are nodes, then you could make a wave, oh japers, you could make a wave like this, or you could make a wave like this, or you could make one like this. Well, yeah, okay. This one's called the fundamental, the next, or first harmonic. The next one's called the second harmonic, and this one here is called the third, and this one here is called the fourth. Okay, so these are the harmonics you can have with a string. This is actually very important in something like music or piano, where you play music with a string. They do expect you to know this for the exam, but it's kind of easy to draw it because you start off with the biggest one you can make, and then the next biggest, which is 2, and then 3, and then 4. Okay, and just remember this is also called the fundamental, the first one. Yeah.
Do we need to know the definition of fundamental?
I suppose no, because they never actually ask this in the exam. What they do expect you to know is the picture for the fundamental.
Draw the picture.
Yeah. Yeah.
They depend on the frequencies.
What do you mean?
If I want to make the one harmonic two harmonic.
Oh yeah, they're different frequencies. Yeah, yeah. We'll do some calculations later. True that? Yeah. Continue. Yeah. Does anybody play any instrument? Anybody? No?
Audrey.
Audrey? Don't be shy, what do you play?
I play the piano.
Ah, so you can appreciate the strings vibrating, then they correspond to different notes. Do you know what I mean? Like, 'cause the piano strings, they all have different lengths, don't they?
Yes, sure.
You don't look under the piano?
I do, I just look on the cover and look from the top.
Yeah. It's all a string piano, isn't it? Yeah, yeah, yeah. So all the strings are different lengths, don't they? Yeah. No, they do, don't worry. This corresponds to different notes. This one here would have a different pitch if you could hear this vibrating compared to this one here. Continue. You get the same thing in musical instruments that use wind rather than a string, something like this. You can have a standing wave. Now, this is a little bit harder because at least with the string you can see that you have a node and a node here. But if you have an instrument like this, or like this, no, well, my question is, what do we have at the ends here? Do we have nodes or antinodes? If you have a sound wave inside these pipes, it's a bit like the string here, the guitar string, except we need to think about what we have at the ends. And it might not be easy to see, but I'll tell you what it is. When it's closed, you actually have a node. Okay? And when the end is open, you have an antinode. So the biggest wave I can make here, the fundamental wave, is this one that starts at the node and goes to an antinode. It's only a quarter. It'd be you could get it 4 times. Yeah, that this is 1/4 of a full wave. But for this one, when it's open at both ends, these are both antinodes. Both antinodes. What's the biggest wave I can make? Is
cosine wave.
Yeah, like this. How much of a total wave is that?
It is quarter.
Is it a quarter or is it a half?
No, the half.
It's a half a wave. Yeah, because it would still have to come down.
Yeah. It's half.
It's half.
Yeah.
Oh, so ugly. Anyways, the point here is at open ends of pipes you have antinodes, and at closed ends of pipes you have nodes. And I don't really think. No, I guess you could have it closed at both ends, and then that would be a node to a node. But that's the same as the guitar string that we did a moment ago. The same picture. I think I have this drawn if you want to draw it nicer on the next one. But it's worth noting that it's antinode at open ends and nodes at closed ends.
Just when
Yeah, when you have a sound wave inside a pipe, which is usually for an instrument.
Antinode is at an open end, is right? But it's connected with
Yeah, I don't know what's happened in this picture because I have no idea how this instrument works. I don't even know if there's a hole at the end here or if it's all closed until she opens one. I know there's an Irish instrument called a tin whistle, which is open at the end for sure. I'm not sure about this instrument though, if it's open or closed at the end. Would you know, Audrey? Is there an open or closed end here?
I think
It's open at this end, you think? Okay. Not important for us.
Yeah.
Okay, continue. So, there's a word you might need here, resonates. So this pipe, when you're playing one of these standing waves, we say the pipe resonates. In other words, we can hear a musical note. That's all really. Resonates just means that you have one of these standing waves. That's all. So, continue. Now, this you have to draw. Before you draw it, it's a little bit confusing. We talked about this one here, first harmonic, also called the fundamental. When it's closed at one end and open at the other, we have a quarter wave. Open and open at both ends, we have a half wave. This is the next picture. How much of a wave do we have? We have one wave, is it? Yeah.
It's okay.
3/2 of a wave. 2 waves and 5/2 of a wave. Yeah? And this one here we have a quarter of a wave, and the next one gives us 3/4, and the next one gives us 5/4, and then 7/4, and then 9/4. Now, unfortunately, the naming is a bit confusing. We call this the first harmonic, we call this the third, the fifth, and the seventh. I know, it's terrible. Whereas here, we call this the first, the second, and the third. Now, you might think that's stupid, and you're right, it is. So there's another word we can use here that describes both here called overtones. you start at fundamental, and both of these is called the first, the second, and the third, and the fourth overtone. But I'm sorry to tell you that we don't use this one in the exam. So in the exam they will only use harmonics. So it'll be quite easy to mix these up. But if you want a little bit of help here to remember, you notice that for these ones the numbers match. Can you see that? Third harmonic 3/4, fifth harmonic 5/4, 7 7/4. Okay, and if you look here, I think you can do something similar here. If you change this into, what's that, 2/2, 3/2, 4/2, 5/2. Can you see that? This one's 4/2. 4/2 is 2. Then you can see that this matches up again with the top. So the second harmonic is 2/2. Third harmonic is 3/2. Fourth harmonic is 4/2. Fifth harmonic is 5/2. So the number of the harmonic matches the top of the fraction. Yeah, you need to draw this beautifully and perfectly in your notebook.
So you say this is first one harmonic.
4 is string. Yeah, you see, life is difficult now.
And then this is for sound wave.
In a pipe.
The high.
Yeah.
Different.
Come in. I just saw your text message there. Yeah.
And you felt chill when
I did, yeah, I got cold all of a sudden.
So that's
so great.
We're looking at harmonics here. These are musical instruments.
It'll be interesting to see now how we're going, because we're using the string for the presentations next week.
Yeah,
And
should
what's
be
the best way
okay.
to set up, like, you know, obviously we have the windows, the blinds down, but for the students.
For the monitor? I'm not thinking, no. Everybody can see this fine with the windows open, can't you?
Maybe that will, yeah.
Yeah.
Oh, it makes such a difference, because in the past when we were using the projector, we had to have it quite dark.
Yeah.
Quality wasn't great, so you couldn't really see the students. And of course, part of the mark for presentations is how you present yourself, you know.
Remember doing this?
Funny enough, that wasn't in the leading of it. The harmonics wouldn't have been, but I did musical theory.
Oh.
So I would have. I can't.
But you would.
Immediately the figure. I recognize
Overtones is a word you're familiar with.
Yeah, and harmonics, like on
Yes.
the guitar, there's a particular way you can hit a string.
Yes,
that you get.
Audrey plays the piano.
I know.
I do.
I do. Actually, I was thinking, have you been using the rooms in Griffith? I've been thinking of going in myself, because I used to play the piano years ago, and I just stopped because
we insist on a duet sometimes.
Oh,
so.
fantastic!
Absolutely, yeah. Now we just have to
Now
decide which one is singing between the two of you.
I'm very, very rusty. Like, I stopped doing proper piano 20 years ago. I probably need 2 years. I probably need 2 full years to get back
Catch
to
up.
the same. Oh yeah, but it's just my muscle memory, you know. I don't even think would I be able to do my octaves properly anymore.
You're able to keep practicing and keep the skills going then for us. How often do you get to practice?
Recently, at least once a week.
Oh, good. Okay. Good
Yeah,
stuff.
'cause there's a music school, right? You know, like
Yeah,
the
yeah.
Hodgepodge, lots of different places.
So you can use the piano there.
Yeah, we went in and they were really nice. Said yeah.
Wonderful,
Yeah.
wonderful.
Yeah.
So what have they got here? Chemistry book?
I have chemistry books.
Okay, great.
not present.
Huh?
Not present.
Not her?
Present.
No, not a present. Indeed
Yeah.
not.
No. So what I'm going to do, guys, I'll let you keep working away. I'll hand out the chemistry notes, but then there's a signing sheet. We just wanted to sign that you've received a copy. Yep. We need some note taking going on.
Yeah, they just need to copy this down very carefully in their notebook. No, don't worry.
What?
I want to have a quick word with you.
Okay. We can take the semester to physics book?
No. I haven't made it. I have to type it. I haven't put all the slides into the book.
And you should sign there. And then a quick word and I'll stop it.
We didn't take a break today, so as soon as you finish drawing that, we'll wrap it up then. But just make sure you copy it carefully, please, in your notebook.
Do we have a chemistry class today?
I'm going to talk to you in a minute. Alright.
Oh, they're very worried. They're so worried.
Well, yeah. Funny, he taught me a new guitar there like 3 weeks ago.
Oh, great.
And it's ever so slightly deeper in the neck. The width is about the same, but the neck is, I think, not that I can notice it visually, but I can feel the strand, and it must be only a millimetre more, or it could be the height of the strings is fractionally higher off.
You can feel it.
But then, yeah, exactly, because after playing and,
you get used to it, yeah.
I know I have to do the whole, the last gas is building up, and it's amazing, like, the tiniest little difference, can have an impact.
Piano and guitar.
Well, I think with piano now, I'd say I'd have to go back.
Okay.
Yeah.
So we could have guitar and piano then.
Guitar, piano, yeah.
Yes.
But in a very different way. Because I wouldn't be able to vamp on a piano because I only did kind of
heavy metal then, is it for the guitar?
But then the guitar, no, I did that myself because I knew enough theory.
Of the piano.
Yeah. But I wouldn't be able to play a scale on the guitar.
All right, okay.
The opposite of the scale.
All right, okay.
There you go.
Have you all got your chemistry book there?
Everyone has a chemistry book. Okay, so because Lorraine isn't here today, you are free to go after this class, okay? But you now have your chemistry notes, and you'll notice in the first lesson of the chemistry notes, it's basically stuff that you have to sit down and learn, okay? It's about nomenclature, which means how you name the different chemicals, and you have to learn all of the endings, like what does OL mean, what does AL mean, what does ENE mean. There's lots of stuff you can sit down and memorize, and there's also some exercises for you to work on. So it's the first lesson in those notes. You can actually work through it yourself. You don't need any.
And I think I have the feeling, I'm pretty certain of it, that this is exactly the type of thing that Lorraine would give a test on in class, because she would really want you to have these memorized. So even if I suppose she's not in, they should perhaps even expect that they could have a test on this. Yeah. No, I'm telling you, like, seriously, like, I would bet good money that there would be a class test on this stuff, because Lorraine really insists, as you probably know, on making sure the students memorize all their vocabulary for chemistry.
And there's a lot in that.
There's a lot,
chapter.
Yeah.
Especially if you haven't come across it before, if you don't know your suffixes, it can be messy. So I'm also going to send you on then, remember I gave you a paper at the beginning of the week? Yeah, I'm going to send you the mark scheme, but I'm not going to print it out, I'll just send you it by email. Okay?
Can you take the chemistry class tomorrow?
Pardon?
Chemistry class tomorrow.
What about it?
We can.
Well, we don't know. Unfortunately, it's kind of a day-to-day situation. What time is your chemistry class tomorrow?
Afternoon maybe.
Well then you're fine, because we'll know in the morning, we'll keep you updated, as much as we can.
Or you might have a test.
Or you might, there you go, you never know.
You just don't know. Tomorrow we'll find out.
Okay.
Yeah. Alright. Do you have this taken down?
Yeah.
Wrap it up then? Okay, we'll leave it there, so. No, okay.
Can I just ask you a favour?
Yeah. Wow. These must be beautiful diagrams then.
bring back something. Oh, I think we're ready center to buy food. What? Oh, oh, who are you? Oh, I'm gonna eat lunch first.
Yeah,
I'm gonna buy food.
eat that. Yeah.
Not for like
in with
the Lord was
It's like through you and for you.
So do we eat that?
yeah, right.
Because you go, let's say you bring back, then he's bringing
Because
because I have to bring back for her also.
Oh shit.
Why?
Oh, please.
That's what
Yeah, let me bring it away.
What time is your 2:30. I can open it. Yeah.
You sure? Yeah, let me bring this. No. Really? You job. Good normal color.
It's like
I think.
Do we have this now?
Yeah.
Oh, MG.
Considering euros don't crack.
What?
No, nothing.
€3 a pack?
No.
You're turning a bit into a Wookiee there with your, it's starting to rub off on you.
Like 10 boom.
Oh, no, please, no, these have names, notes and anti-notes, you can use that.
Remember.
Anti,
No,
notes, yes,
no, anti, no,
yes,
anti,
yes.
like this. So 10, blah blah. 10.
I don't know, I never counted.
And then 8, blah blah.
Okay, fine.
6, blah blah.
Okay.
2, 4, blah blah. 2, blah blah.
Anything else?
And
Did they ask us to draw or will they ask us to write?
Draw.
draw.
Why?
I saw you take photos.
Look, stop picking on me. I don't make the final exam. I don't make the syllabus.
Do we have like a mid-semester school exam?
Only if you want
Oh,
to.
no, thank you.
I want. Wait, one.
We will decide later.
No, thank you.
You are not the class leader. He might want one.
I want one.
Yeah, he'll need to discuss it with the class.
Yeah. What do you want?
What class are you canceling on Friday?
I want.
Well, let's see. Oh yeah, can I? What's the?
No, it didn't give up.
Guys, wait, Friday. We have how many physics classes on a Friday?
Two.
Two.
One is definitely one.
Yeah.
One is
You can check it. And no physics on the back.
You see, what we said was the.
10 to 11 plus.
Hang on, no, just
Okay.
listen. Guys, can we all listen, please? Please. Are you really listening? Shamsa, listening? We have assessment support at 1 o'clock and physics at 4 o'clock. Okay? But it doesn't really matter which is physics and which is assessment support. Agreed? So we'll just call both of them physics. Okay? So we have physics at 1 and physics at 4. What I was thinking is we could move the class at 4 until, what did we say? 10, wasn't it?
Yeah.
Same room.
Yeah.
Just move it to 10.
Yeah.
Okay? Yeah. However, since we had an extra class today, I suppose we could cancel the class at 1 o'clock and make the 10 o'clock class the assessment support.
That's good.
You don't want to.
Yeah.
Physics assessment support, yeah.
What is the winning?
Huh?
10.
So you have class at 10
Yeah.
to 11.
Deserve.
And you should have had class at 1 o'clock, but because we had an extra one today, we can cancel that. Or not. I mean, I can do it as well.
More classes.
More classes are fine.
Yeah.
I don't know if you're being serious or not.
I am.
Are you?
We'll decide later.
Well, do you know what? In fact, you don't even have to decide now. Maybe when 10 o'clock on Friday comes, you said, bring on more physics. More physics, please.
Could be.
Could be, or could be not. So anyways, I will see you Friday at 10 in CAV. And then you can decide what you want to do after that class.
More.
We can have a vote.
More.
We'll have a vote. But really the only vote that matters is mine. But we'll have a vote. The dictatorship. Okay.